Here I'm showing you an ionic bonding simulator. This allows us to visualize what do we mean by ionic bonding. There's a metal ion here that's positive. There are 3 chloride ions, each is -1. The metal ion, I can control its charge between 0 and +4. I'll start it with a +1 charge, and we'll see what happens. Here you can see the metal ion is bonded with 1 chloride ion. The other chlorides ran away, but we have a bond. This is an ionic bond because it's based on positive and negative ions. If I change the charge to 0 on the metal ion, now we can see there is no bonding at all. The chloride ions are negative. Let's bring them back. The chloride ions are negative. There is no positive to attract them. There is no bonding possible here. What if I make the charge of the metal ion +2? Now you can see the +2 metal ion attracts not 1, but 2 chloride ions. And this is a general truth. For every plus, there is a minus. If the metal ion is +2, it will attract 2 negative charges. In this case, that means 2 chloride ions. They're bonded together. That's ionic bonding. I'll now make the metal ion +3. And we can see now it bonds once. It bonds twice. It bonds 3 times. The +3 will attract 3 negatives to go with it. This is the rule for every plus, there is a minus. Here's the first question for you. Which picture is wrong? So these are ionic bonding pictures. Take a look. Is it A, B, or C? We'll start with B. B is great. Okay, good, because you can see there's a +2 to go with a -2. For every plus, there is a minus. We're done. A is also okay. You can see there's a +4 in the middle, but it's balanced by 4 negatives around it. For every plus, there's a minus. But C is bad. We have +1, only +1, and a total here of -4. So that one's the bad one. We're looking for 3 skills. First skill is to be able to draw a picture. Draw a picture. Second skill is write a formula. That's symbols, and then write the name. First example is already done for you. Here's the picture. You should see that we have equal plus and minuses. There is a +2 here and 2 -1s. That adds up to 0. That's what we're looking for. That's why it is 2 of these chlorides for every 1 calcium. The formula you can see says that 1 calcium and 2 chlorides. The reason is because the calcium is a +2, each Cl is a -1. Name is very simple. It's calcium chloride. You just say the 2 names. The positive ion goes first, both when you write it as a formula and when you write it as a name. Now we're looking at the second one. It is potassium, K+, that's a +1. Sulfide is a -2. Picture comes first. I am drawing a K with a +1. If it's +1, you'd usually just write plus. Sulfide -2. I need to make this so that for every plus, there is a minus. Equal numbers of pluses and minuses. That's not true at the moment. I have 2 negatives. I have only one positive. The way you fix that is by adding another potassium. Now there are 2 potassiums for every sulfur. That gives us a ratio that can be written this way. The formula is K2S, 2 potassiums for 1 sulfur. The name is potassium, positive first, sulfide, negative last. Boom. All right, now we need to learn how to use the periodic table to determine this if it's not given to you. If the problem or the teacher doesn't tell you what the charges are, how do you know? So here's your periodic table. It arranges elements in columns. You have to be able to find the element. So I just looked at potassium. Here it is. It's in a family with sodium and lithium and hydrogen. And you can see at the top of this column, there is a charge given. This is the ionic charge of the elements in this column. The element is not always charged. If it's hydrogen gas, it's not +1. If it's potassium metal or sodium metal, it's not +1. But when these combine as ions, they have a specific charge. So that's how I knew that potassium is a +1. Potassium with a +2 does not exist. Potassium with a -1 does not exist. This is the only choice for potassium. Non-metals are here. Those are the negative ions. So almost always when we make ionic compounds, we're choosing one metal and one non-metal. The sulfur is here. You can see it's in a column with oxygen, selenium, tellurium. The ionic charge of a sulfur is given here, -2. Therefore, this is how I knew, and the page told you, that the sulfide ion is -2. There's no such thing as a sulfide -1 or a sulfur +1. That's it. These are the only choices. They're given on the periodic table. So here we can apply that. If we're looking for a compound of magnesium and oxygen called magnesium oxide, we need to know the charges. What's the charge of magnesium? What's the charge of the oxygen as an ion? We go to the periodic table to find that. Here on the periodic table, I need to find magnesium and oxygen. Magnesium is a metal. It's right here. You can see its charge +2. Oxygen, on the other hand, is here. It's a non-metal. Charge is -2. Once we have the charges, it's easy to see it's Mg +2, and oxide is O -2. So we just need one of each. We don't need extra copies of either one. It is simply one of each. That means the formula is MgO, and the name is magnesium oxide. Done. Here's example number 4, aluminum chloride. We need to know the charge of aluminum. We need to know the charge of the chlorine. Go to the periodic table and find those charges. That will tell you what to do next. If you did it correctly, aluminum is +3. Chloride is -1. I'll just write minus. You can see they're not balanced yet. We need an equal number of pluses and minuses. To fix it, add another chlorine, or chloride I should say, and another chloride. 3 chlorides for 1 aluminum. And you write that as a formula, AlCl3. That's the formula. The name is aluminum chloride. Just say the positive first. It's always the metal. Say the negative last. It ends with IDE. There we go. Last one is a little tricky. Barium nitride. Barium is Ba. It's number 56 on the periodic table. So you have to find it first, otherwise you won't know its charge. The page is telling you that nitride is N with a -3 charge. Barium, Ba, plus 2, same family as magnesium and calcium. Nitride, N minus 3. You can see they don't balance in a 1-to-1 ratio. They don't balance in a 2-to-1 ratio either. So I need to get to a common multiple of 2's and 3's. 2's and 3's, you can make them even out if you make them both 6. So now I've got 6 negatives. -3, another -3. That's 6 negatives. I need 6 positives. Right now I have 2, 4. Add 1 more barium. I will have 6. 6 plus and 6 minus balance out to be this picture. How to write it? 3 bariums. So you write that at the end, Ba3. 2 nitrogens. Write the 2 at the end. That's the formula. Name is just barium nitride.